Okay, thanks everyone for attending this webinar. I hope everyone's staying safe and well. During the webinar, if you have any questions, please go ahead and ask them via the GoToWebinar interface. There should be an area there for questions. We have 15 minutes for questions at the end of the webinar. If we don't have time for all of them, we're going to follow up afterwards via email. Please ask questions at any time during the webinar. We'll get to them at the end. If you'd like to listen to the webinar again at a later date, we have a recording available that we're going to put on our website and YouTube channel. The subject of the webinar today is getting started with fire and gas mapping. So this is a very basic look at fire and gas mapping. We're going to look at a lot of subjects. Of course, we only have an hour, so we can't get into great depth on each one, but I at least hope to give you a good head start for your fire and gas mapping. A little about me before we start. My name is Oliver Haynes. I am the co-founder of Insight Numerics. My day-to-day work involves developing Detect 3D fire and gas mapping software and Influx CFD software. Before starting Insight Numerics, I was a sort of process safety consultant. I was primarily doing consequence modeling using CFD for dispersion, smoke, fires, things like that. And before that, my background is that I have a PhD in computational fluid dynamics and a master's in aerospace engineering from the University of Manchester in the UK. My real interest is in algorithm development and CFD, optimization, things like that. I'm really interested in trying to bring those numerics to useful applications in our industry. The company I founded together with Alan, Insight Numerics, we started in 2013 in Boston in the US, where we're still based. We develop and maintain two software products, Detect 3D for fire and gas mapping and Influx for CFD modeling for ventilation and dispersion and later fire. We're quite unique as a company because this is all that we do. We simply sell licenses for our software and we support our customers on their projects. We don't bid on projects, we don't do any consultancy, and we do that because we want to maintain our goals to be aligned with our customers. We don't want to compete with our customers on projects. Both Detect 3D and Influx are widely used, in particular Detect 3D. We have a very broad customer base that includes the oil majors, BP and Chevron and others, right through to the major engineering companies, very widely used there for major projects. And then right through to the very large consultancies down to one-man band consultancies. So it's really the whole range of companies use both Detect 3D and Influx. We've supported hundreds of projects over the course of Insight Numerics. We've got a very broad view of what people are doing with fire and gas mapping and who's doing it and what problems they're running into, what benefits they have from using Detect 3D. All of those things give us quite a unique perspective, and hopefully I can share some of that perspective with you today. So the goals of the webinar today are quite simple. The first is that we want to help you perform fire and gas mapping projects. even that if that just means getting over that initial stage of feeling that you can do it and it's not that hard and you can get started with a fire and gas mapping project. We're also looking to familiarize you with the most important topics in fire and gas mapping. This is not an exhaustive list and we can't go into detail on all of them, but just the key points, what you should be looking for in a fire and gas mapping project and where to find information. Finally, we're going to show you how easily you can perform fire and gas mapping projects using Detect 3D. So before we get into the main meat of the webinar, we have a quick poll, which I will just launch now. The poll is just asking your experience level with fire and gas mapping, right through from totally new to fire and gas mapping, to sort of managing fire and gas mapping projects but not doing it yourself, to somebody that's completed a few fire and gas mapping projects and an expert in fire and gas mapping. We'll just wait a few seconds while those answers are collected. So we have a mix of people on the call. The majority are completely new to fire and gas mapping, and then we have some that have outsourced fire and gas mapping but haven't done the project themselves. So that means the majority of people on the call have never done a fire and gas mapping project themselves. So this is great. This is definitely the webinar for you. We have a few that have completed fire and gas mapping projects, and one or two experts on fire and gas mapping. So that's all good. Everyone can pitch in with questions or comments and as we go along. So fire and gas mapping projects are kind of interesting because nobody goes into a fire and gas mapping project with training. Everybody who starts a fire and gas mapping project comes in from their own kind of angle. When I was first starting doing fire and gas mapping, you can see that my background was CFD and consequence modeling. Other people doing fire and gas mapping projects will come in from their own particular area of expertise, but often that's not the complete set of knowledge that you need for fire and gas mapping. And this is why fire and gas mapping can sometimes feel quite intimidating to start, because everybody who starts doesn't have the complete set of knowledge to complete the project, and that can be quite difficult. The good news is that everybody's in this camp. Okay, everybody who's used Detect 3D and we've supported on projects, they've all started from this point. And as long as you have a high degree of professionalism and are willing to learn, fire and gas mapping is not too difficult. It's very easy to find information, to learn the key things that you need to learn, and be able to do the projects. There is no such a thing right now as a fire and gas mapping engineer. There's very few people that do this really full time and will regard themselves primarily as fire and gas mapping engineers. People are coming in with their own backgrounds and experiences from different angles. What you do need to be aware of is what you don't know. What are your knowledge gaps? And also how to find information to deal with those. That's probably the most important thing with fire and gas mapping. It's okay going into a project, as I did when I started fire and gas mapping, not knowing how detectors work. Okay, you might just not know the very basics of how a flame detector works or a gas detector works. That's fine. You can find that information out, you can learn it, and we're going to give you the resources to do that. The other problem with fire and gas mapping is that there's very little literature on the subject. If you're looking to find a handbook of fire and gas mapping or a document that's going to walk you through how to do it, you're not going to find that. There are resources available, but there's not one central resource. It's done differently in different parts of the world. People have lots of opinions about how it's done, and there isn't one convergent document distilling all of these methods. So again, that's kind of makes it difficult to often start a fire and gas mapping project. But looking first at the kind of detector technologies and how I would recommend you approaching the subject of detectors if you don't have this knowledge already. Of course, if you're an expert on detectors, then that's great. But if you're not, I would first recommend going to the UK HSE website. They've got a lot of really good guidance about detection technologies that they've gathered over years of experience. And if you just put some simple search terms in, you can come up with some really useful information to get you started. This is just one that I picked out at random. I'm not particularly recommending it. I'm just, it's the first that came up looking at gas detection, for example. Then I would recommend that you look at the project itself. Often projects will have performance standards or guidance documents that talk about the selection of detector technologies. These will vary based on company to company. Some companies will be more conservative and use older technologies. Some will be more forward-looking and use newer ones or have experience with different types of detectors on different projects. So be aware of any project-specific guidance that you might have. The next place to look is the manufacturer of the detector. More often than not, when you perform fire and gas mapping projects, the detector has already been chosen, or the manufacturer has been chosen. Sometimes that's not true. Whichever way around it is, the manufacturer's data is always a good place to really learn about the detectors that you're using on your fire and gas mapping project. Each manufacturer has public data that you can just download and look through on their detectors. They'll talk about range, specifications, important things that you need to really understand, like response time, the sensitivity settings associated with response time in each range, different approvals that they have, and also testing that they've done for false alarm immunity. That's something that you really need to take care of, is thinking about what are the possible sources of false alarm on your site and looking at how your particular detector can distinguish between false alarms. Once you've got that data, you can approach the manufacturers themselves. You can email them, contact them. In my experience, they are very willing to talk about their detectors, and often they'll point you to more resources than are available online. We have many contacts with manufacturers. Some, like Numerics, use Detect3D day to day. And if you need contacts to manufacturers, we're very happy to share those with you. This is something that we do to support many of our projects. When we have very specific questions about detectors, we'll pass that on to the manufacturer and connect Detect3D users to the manufacturer. So yeah, Of course, look at the background of how these detectors work, but I'm not going to talk about that. I really wanted to direct you to resources that you can use to learn more about the detectors on your project. The other key important element to a fire and gas mapping project is to understand the performance standard that you're working with. Each fire and gas mapping project normally has a performance standard. The well-known performance standards are the BP and Shell standards. They're used very commonly and sometimes referred to on projects that aren't BP or Shell projects. But there are no independent, internationally recognized performance standards for fire and gas mapping. This is something that people always look for when they start. They want some independent advice on how to do fire and gas mapping, and there isn't any. If the closest is the ISA TR84 document, but it's not a performance standard, it's a guidance document. It's a guidance document that is useful for sure. I like the angle that it takes on fire and gas mapping, but it is an angle. It's not representative of all of techniques that are used in fire and gas mapping across the industry. So it's not to be used as a performance standard, but certainly download and read it and take from it what you can. But on your actual project, there are certain things to look for in the performance standard. First of all, make sure you read it. That's one huge aspect of performance standards. They're normally not that long, but often there will be nuggets of information in the performance standards that you won't find unless you read the whole thing straight through. The particularly important things are looking at detector specifications. So there'll often be advice on what settings to use, sensitivity, response times, the types of detectors that you want to use, and also particular types of detectors for different types of areas that you want to detect. Secondly, what you're looking for is how to classify your hazards, how areas are classified on your project according to the performance standard, because each project will classify them slightly differently. So it's not, you can't take experience from one project with one customer and then just directly apply it to the next project. You have to go back to your performance standard and understand how this particular company views hazards and how that relates to fire and gas detection. The other thing to look for is the coverage requirements. So how much coverage of detection coverage is needed in different parts of your site. This is a key thing to understand. Not only just how much coverage, but how strict are the requirements for that coverage. Some performance standards are very prescriptive, so they'll say you must have 90% 1 out of n. Other performance standards are much less prescriptive and give much more scope to individual engineers or the individual project itself. Again, that varies greatly from performance standard to performance standard. So it's something to really understand. Is this something that I can have a little bit of room with, or is this something that's very prescriptive? Sometimes you won't have a performance standard on your project. And what do you do then? Well, the first thing I'd recommend is if you can get a hold of the QRA on the project, if it's got one, then try to align what you're doing with fire and gas mapping with the QRA. You can normally do that because the QRA will have details, the different hazards on the site. You'll normally have an inventory in the QRA detailing some level of detection to calculate the risk associated with fires and gas leaks and explosions. So if you know that, you can kind of get a sense of what coverage you need to get from the QRA. You can also benchmark against previous projects. So this could be previous projects in that the customers taken on. It could be similar projects in your area. But that's something where you're really making using an engineering judgment to really fill in the gaps of not having a performance standard. And then also sometimes there are local national guidance and regulations about the types of the performance that you need. So you need to be aware of those as well and take them all into account. It's important how to view the performance standard as a baseline. It's a minimum requirement. You can comply with a performance standard and not design a very good system. You can comply with a performance standard and have too many detectors, or have areas that are quite important that don't have coverage. So don't see a performance standard as something that if you can comply with, then you sort of breathe easily. At the end of the day, we're engineers and we should do a good job on the project. And the performance standards are kind of minimum requirement for that. Another aspect of fire and gas mapping is the software. So you will need to use software to analyze where you should put the specifics of where you put gas and flame detectors. I would advise approaching software quite late on in your thought process. You first really need to understand the performance standards, the detector types that you're using. You need to look at the CAD for your site, understand the process conditions, hazards, things like that. Do all that first. Don't look to software to guide you through that process, because that's not really what the software is for. The software really is for letting you execute on the project. So you've decided all of these various parameters first, and then you're using the software to execute the specifics of setting up the fire and gas detectors. Where the software products differ is the ease of which they allow you to do that process. In terms of our own contribution to this at Insight Numerics, we released Detect 3D, and it was the first commercially available 3D fire and gas mapping software. Prior to Detect 3D, everybody was still using 2D CAD on 2D plans. And in fact, when I first saw that, when I first started looking at fire and gas mapping, I was very shocked, I have to say, that people were doing such basic analysis in 2010 is still, I mean, it was quite unbelievable to me, especially coming from a CFD background where 3D models are the norm. And I decided really that it wasn't good enough and that we should be using 3D CAD, and that's always been part of Detect 3D. That was our main contribution, to bring those 3D models into fire and gas mapping. And nowadays, using a 3D model for fire and gas mapping is the standard, which is very good, in my opinion. It should have been a long time ago, but we're now there where using the 3D model is a standard. The other part of 3D fire and gas mapping is looking at coverage as volumes rather than areas, but we'll look at that a little bit more during the demonstration of Detect 3D. The main technologies for fire and gas mapping for flame detection in particular is ray casting. That technology is one that I developed in 2010. The trick for ray casting really wasn't the ray casting itself, but making ray casting very fast on very large CAD files. If you use ray casting, you can really tell what the flame detectors can and can't see. And the original paper on this was Hazard's conference paper in 2011, where those methods were detailed. For gas mapping, it's very different to flame. The most common method is to use spherical gas clouds, but there's a huge, an interesting debate right now on geographic mapping, which is using the spherical gas cloud approach, versus the risk-based mapping using CFD. And of course, we are developing, or we have developed, Influx CFD for risk-based gas mapping and already deployed that on some of our customers' projects. So it's very interesting transitional time for the gas mapping. Finally, the other thing I was shocked about when I first looked at fire and gas mapping really wasn't just this basic level of technology that was used 10 years ago, but also that there was no validation. And again, you associate CFD with validation, and I was very surprised there wasn't any done at all for validation, published that is. And so we've tried to fix that. We published the first validation of a fire and gas mapping product, Detect3D, at a recent FABIG meeting with our customers, JGC, where we compared Detect3D to real fires with proper obstructions and to correlate those fires with what Detect3D was saying. So I'm going to now show you how to use Detect3D on your projects, hopefully to show you how easy it is to use, how simple. So I'm going to just switch now to Detect3D. 1 second. Right. So this is the user interface of Detect3D. The first place that most people start with fire and gas mapping projects when they're ready to use the software is the CAD. So you typically have a CAD file in some format, and you can load that CAD file into Detect3D. You can import 3D CAD, 2D CAD, or if you don't have CAD, you can create new geometry. But most projects have 3D CAD files, and the most common file type people use is the DGN file type, which can be imported from, you can export it from PDMS or SmartPlant. So that's very common. Also, DWF files are very commonly imported into Detect3D because these can be output from Navisworks. So if you have Navisworks or you have your project in Navisworks, you can export the project to DWF and then import it into Detect3D. I'm going to show an onshore project, onshore CAD file. This is quite a simple, small CAD file, but it could be something where you have a larger project and you're cutting out a smaller piece of that project, and this would be something that you might look at for just a small project. Normally with Detect3D, the CAD files are enormous, so this is a very simple CAD file. So we'll look at flame detectors first. We're going to add a flame detector. We can just use the mouse to pick out where we want the flame detector to be. And if we preview that, you can see the flame detector itself. This is the model of the flame detector. And then this region shown in red is the detector's field of view. That field of view is in 3D. you can use any field of view with Detect 3D. So we've got one here showing the sort of maximum range and viewing angles in plan and side view. There are lots of things you can do to edit these properties, and you can use it with any manufacturer. And we have some manufacturers' data already in Detect 3D as well. So let's say we want to look at these two vessels over here, and so what we would do would be to point the flame detector towards those vessels and also give the flame detector some declination, and then simply add that flame detector to the project. So you can see that flame detector now is pointing towards the vessels, and we can see how well they're covered. The technology of Detect 3D is to take this unobstructed field of view and turn it into an obstructed field of view. So this is the one with the ray casting. This is showing the CAD pieces taken out. And it gives you a much more realistic view of what the detector can actually see. So the software casts out tens of thousands of rays and sees what all of those rays hit the CAD file, and then it reconstructs the field of view based on that data, and it all happens very quickly as well. So we can take that field of view, but what we really want to know is the coverage around these vessels. So we can turn that off. To calculate the coverage, we do need to tell Detect 3D where we want the coverage to be. And to do that, we build a zone around the vessels. We can see that zone here. And already the software will tell us how much coverage we have in that zone. So this is telling us that we have 30% zero coverage and roughly 70% covered by one or more detectors. Obviously, we have 0% covered by two detectors because we only have one detector. So this is a kind of key result for your fire and gas mapping projects. Often your performance standard will talk about the detection coverage, and this is the result that they're talking about. So once we've got that data, we do want to see where the coverage gets more insight into which parts of the zone are covered and which aren't. And you can see that with the contours. The contours are just a slice of the zone. So they're not showing you coverage in a percentage term at a height. They're just visualizing what's in the zone, and you can put a contour at any height and see the different coverage you have at different heights. But you've got the blue region here showing coverage by the one detector we've added, and black regions showing coverage by 0 detectors. You can see here some shadowing from the various structural members as well. So what we would do here is to say, okay, well, we've got some coverage in that zone, but we ideally want more. So we're going to add a second detector to cover some of these areas that have 0 coverage over here. So I'm going to put a detector on the ground and then raise it up by a certain amount. And then I'm going to change the azimuth angle to try and cover parts of that area that have 0 coverage. And when I add that, if you just take a look at that 0 coverage area, that's now been eliminated. So now you have coverage in that area. So if you did have a fire over there, it would be visible to this detector. We've also now got regions of 2 coverage shown in red, and we can see that on the coverage table where we now have 90% 1 or more, or 44% 2 or more for 2 out of n. The contours are nice to show different levels of coverage, but often a 3-dimensional view of your coverage is really useful. And I've just added that here as an isovolume. So an isovolume is a 3-dimensional surface showing what coverage you have in 3D. And here it shows something really nice. It's showing us that in between these 2 vessels, we have quite a significant area of 0 coverage. You can imagine, for example, some liquid pooling in between these 2 vessels and perhaps igniting. And if that caused a fire, you can imagine that heating these 2 vessels. So it could be quite significant, and yet it wouldn't be detected by either detector. So this is really the key advantage of the fire and gas mapping software, is it's showing you these quite specific aspects of your project that you can then fix quite easily. If I was doing this project, I would say that even though I have 90% 1 out of n, that is quite significant. I really want that to have a detector be able to see in between those 2 vessels. So I'm going to add a 3rd detector. I'm going to put it here, and I'm going to point it down. And hopefully that will then see in between those 2 vessels. If you press add and just keep a look on this area, you basically see that that region has now disappeared. So that's a nice application of how you can visualize 3D fire and gas mapping to improve the coverage on your site. As well as looking at coverage overall in the zone, you can also look at coverage around equipment. Often performance standards will not only have coverage in certain areas, but also ask for coverage around equipment items. And you can do that in Detect 3D just by selecting the equipment and then selecting a radius away from the vessels or whatever equipment you have. Vessels. And when you add that region, it builds this volume around those vessels, and you can get coverage in that region separately. So this one's showing us something quite interesting. It's saying that even in the zone we have excellent coverage, 96% 1 or more. The coverage 1 meter away from the equipment is slightly less. Now it may still be acceptable, but it's still useful information to know that the coverage goes down as you get closer to the equipment, which is not something you would want. You could accept that, or you could add more detectors to try and improve that coverage. Now there's various more advanced aspects of Detect 3D, such as the analytics showing you which detectors are most effective. There's also optimization, which can automatically reduce the number of or optimize the number of detectors that you have on your site. But I don't have time to show all of those right now. I do want to finish the demonstration looking at gas mapping. In Detect 3D, you can add point, open path, and acoustic leak detectors. The point gas detector is simply added by picking a point and then adding it to the project. And you can see a representation of that point gas detector there. Now, flame detectors, of course, have regions that look out from the detector looking for fires, whereas gas detectors passively wait for gas to move past them. And the geographic method models that gas moving past as a sphere. So if you imagine on your site a sphere moving around all the areas on your site, sometimes that sphere will be detected by the gas detectors and sometimes not. The amount of times that it's detected gives you your coverage, and that's the geographic method. You can effectively build up how influential this gas detector is at detecting that gas cloud, and it has the same radius as the gas cloud. This blue region is not the gas cloud, it's just showing you how effective that gas detector is at detecting a certain size of gas cloud. If we increase the size of the gas cloud, the detector gets larger. Effectively, effectiveness gets larger because we're looking at a larger gas cloud. So what we can do is simply go around and add additional gas detectors to increase the coverage. We can also add open path gas detectors. So we can put in the locations of the transmitter and receiver of the open path gas detector. Here we have a visual of the open path detector. Now, Detect 3D also will warn you if the beam of the open path detector is either blocked by geometry in the file or close to geometry. Again, that's something that you should look for in your performance standard. The effectiveness of open path detectors is more of a sausage shape. It's looking at how much of the gas cloud intersects the beam and integrating that to get the overall signal. Finally, you can add acoustic leak detectors. So we'll add one here. And that acoustic leak detector listens for the ultrasonic signature of leaks. I would highly advise you to ask manufacturers for specific information about their acoustic leak detectors. Once you have that information, you can add them to Detect 3D. And the kind of coverage that you get with a gas mapping project typically looks like this. So I've added here the contour showing the coverage. And this is very kind of common looking contour for gas mapping. This is basically saying that if you have a gas cloud that's centered in the blue regions, it only overlaps one detector. If we have a gas cloud that's in one of the red regions, it overlaps two. The 3 is for the green regions and 4 is for the yellow regions. And of course, you can then translate that, just as with flame detection, you can get an overall coverage of the gas detectors, not just in the zone, but also the subzone as well. So often the zones and subzones will be the same for fire and gas, but sometimes not. All of these results can be exported to Excel. You can also save this project file and use Detect 3D sometimes without a license, and that gives you a free viewing mode where you can view the results, and that's useful to transmit the information to your colleagues or to your clients or just store for the project. So I've got a couple of minutes over. I do want to bring back the presentation and open up the floor to various questions. I can see we've got quite a few questions coming in. I will say that if you want to ask us anything later, you can email us. If you want to have a look yourself at Detect 3D or Influx, you can download it from our website. But Alan, I'll ask you, do we have any, can you kick us off with some of the questions that we've got coming in?
Hi, Ollie. The first question is regarding to an older facility. not having a 3D model, but they're wanting to do a mapping assessment. Is there any way for Detect3D to have a pseudo 3D model because the client doesn't want to pay to develop a full 3D model, because that's quite expensive?
Yeah. So the question is whether you need a 3D model if you don't have one. So yeah, you can create 3D models in Detect3D very quickly. There's a full kind of capability for developing them. With fire and gas mapping, you don't need a huge, a very complicated CAD file. It's not like explosion modeling where you need to include a lot of the details. If you include the major details on your site, you can get a very good answer, a much better answer than not doing it, put it that way. Detect3D, for example, let's show this very quickly how you would, in this case, add some more information from CAD. You can create new geometry. Let's say you had a tank here, you can kind of build out a new geometry, add that to the project, and the project automatically updates itself with new coverage based on that new geometry that you've added. So I've just added a tank there, but you can create anything. You can look at piping, you can create, if you had a building, you could easily just create a box to add the building, and the project just automatically all updates itself. So you can see with the flame detector field of view, for example, it's got all of those new items accounted for. So it's very easy to quickly build up a kind of simple project site. It might take a couple of hours, but yeah, you can do it and get a pretty good answer. I would recommend doing that rather than not doing 3D mapping, which is much worse. Alan, do we have another question?
Hi, Ali. Yes. Does Detect3D include data from different detector manufacturers for different sensitivity or settings?
Yes, we have information from several manufacturers on the fields of view of the detectors. Normally, one model of detector may have 50 or more fields of view because they have different ranges based on the fuel type or fire size and the sensitivity setting. All of that is in Detect3D. If you have if you're using a detector that's not in the manufacturer's database, you can add it yourself. The information will be there online and you can download it. I'd recommend doing that anyway, to find the information out about the detectors on your site. And it's very simple to add that information to your project. It's also very easy to switch between different detectors. For example, in Detect3D, but go back, I've got them all now set up as the default detector, but I can change all of the detectors to different models. For example, if I've got a slightly longer maximum range, I can change all of the detectors at once to use this new a longer range detector, and you can then see what effect that has on your site. You can see here that now the rays are much longer, and you can see like how much that impacts the coverage for the flame detectors. It's all very, very quick to do that kind of thing. Okay, next question.
Hi, Ali. We had a few that kind of go along looking at how do I or can Detect3D optimize gas detector positions. So I guess if you could just touch on that a little bit.
Yeah, for gas detection, right. The optimization capabilities in Detect 3D are mainly focused towards flame detection because that's the most common need for optimization. Often on projects, what I've showed you is something quite simple, but where you have a very complicated process area, you might have, 10 or 15 detectors. It's easy to start. It's easy to place the first detector, the second detector, the third detector, but you might not have enough coverage at that point. Okay, where do you place the fourth? But now where do you place the fifth? And have you placed the third incorrectly because now there's no real good place for a fifth detector to go. And it becomes very difficult to really have a good layout when you start getting more and more detectors. That's where the optimization is really good because it can balance the usefulness of each detector and minimize the number that you need. Often the optimization reduces the detector count by 25% compared to a human. For gas detection, often you don't run into that problem because the method for calculating the effectiveness of the gas detectors is much more simple. It's just using the spherical gas cloud. And so the main issue with gas mapping, for geographic gas mapping, is deciding on a gas cloud size. That's normally something in the performance standard. It can be supported with modeling, with CFD modeling of gas leaks if you wanted to get the gas cloud size, but that's normally the issue. Normally, there's no need for optimization of gas detectors using the geographic method. Now, that is not true for risk-based mapping, but we're not going to get into that too much, and we will have a later webinar on risk-based gas mapping where we'll talk about gas detector optimization on that. Okay.
Hi, Ollie. Going on about that risk-based gas mapping, we've had several questions about can you do the CFD dispersion results in Detect 3D, or can Detect 3D and Influx talk to each other as an import and export information, or how do I do risk-based in Detect 3D? These all kind of culminate around the same subject.
Yeah, so this is questions about risk-based gas mapping. Detect 3D is strictly for geographic firing gas mapping. Influx CFD software that we develop can be used for risk-based gas mapping. And yes, those two software products, because we've developed them, use the same code base. So you can export from Detect 3D and load your gas detector layouts into Influx and use CFD to analyze how those gas detectors perform with proper CFD models. You can also do the reverse. You can use Influx to run thousands of CFD simulations to calculate a gas detector layout using risk-based methods, then export that to Detect 3D and calculate what the same layout is with the geographic method. Now, I don't want to spoil the risk-based gas mapping webinar that we will have soon, but those methods are very different. They give you very different layouts for various reasons. But yes, Detect 3D and Influx do talk to each other, and you can use them to look at both different types of doing, different methods for doing gas mapping. Do we have any further questions, Alan? Maybe one more?
Yes, Ollie, sorry. Does Detect 3D account, how does it Detect3D account for wind?
Yeah, so the geographic method doesn't account for wind. This is one of the simplifications of geographic gas mapping, and I will just try and talk about this I'll try and talk about it for 1 minute. But basically, if you think of what you want to do for gas mapping, forgetting about limitations of software, what you really want to do is to be able to model different wind speeds based on your windrows. You want to look at different leaks, different hole sizes, all of that data, and then you want to compile that to calculate your gas detector layout. Now that's pretty much what risk-based gas mapping is. That's really what you're doing. You're going for that ultimate solution of using all of that data. But it's a huge task. Even with Influx, we've made it much easier. But that's only become available in the last 2 years. Before that, you would need to run several thousand CFD simulations, and anyone who does CFD will tell you that that's a huge job, not only just to run that amount of simulations, but to compile all that data into one and use it to calculate the gas detectors. And certainly 20 years ago, when people wanted to do gas mapping, that was not an option. It simply was too difficult. The problem is you can't really downgrade gradually from the physics. You really have to say, well, okay, if I can't look at all of these aspects of them, I'm gonna, you kind of might have to size a gas cloud based on explosion data or some testing that you've got to get a gas cloud size. And then you might say, well, I just don't want that gas cloud volume on my site without being detected. Well, I don't know what shape the gas cloud's going to be, so I'm going to choose a sphere, and then I'm going to move that sphere around. So the physical reality of what you're modeling with geographic method is quite weak. That's the main weakness of gas mapping using a geographic method, not just with the Detect3D, but the method more broadly. That's again what we're trying to solve with Influx. The good thing about the geographic method is it's well supported. It's widely used. It's very quick, so that's why it's still used. But it's a very interesting subject, and I will get into that more on the next webinar, which perhaps is a good time to wrap up anyway. We are going to have webinars in the future about fire and gas mapping, and risk-based mapping seems to be a hot topic that people want to know about, so we're going to have that one come along soon. Please check our LinkedIn company page and the newsletter that we have. Also, we have an events section on our website where we keep up to date of our future webinars. This session is recorded, so it'll be up on our website and YouTube channel. I do want to thank you everyone for joining. If you have any questions, please use the contact information on there. And I do hope to see you all at the next webinar. Thank you all for your questions and contributions.